We're back with the laptop that I found in the sink. So you may remember our difficulty with this was that we had no 3.3 volt on our power button. This is the chip. It's a TPS-A50-E-157. I think this is where the 3.3 volt is generated from before it goes out to our power button. So I was looking for confirmation of this and I was searching for a schematic. So when I went googling for a schematic for this board, the board that's in this laptop is an FTL5SY4. It's a Toshiba. So I went searching for this and let me just bring it back here. The only page that I found, there was a number of pages had the BIOS for this laptop, but not many of them I could find had reference to schematic, except this one. So DIY-laptoprepair.com came up on my search, and this was it here. I'm looking for Toshiba Tecra. It's the Z50 series laptop, but it's the same model of motherboard. So I excitedly started scrolling down through this and I saw this link right here. So when I click on that and just get past the pop-ups, this redirects me to David Nosman's blog. So I say, okay, yeah, let's go, and I hope he hasn't taken down his website, and he apparently hasn't. So this is Mr. David Nosman. He is an SQL guy from the other things I've read about here. However, he said his laptop failed and that's why he needed a schematic for this same model of motherboard. So he went through it and did a little blog and posted up the schematic on it. So when I click repair, it brings me to a page, but I have to unlock it. Now this is in the Irish language in Gaeilge, so a lot of you might not understand this, but this just basically means complete a survey in order to unlock the page. Now I've done about 20 or 30 of these and I cannot unlock this thing. I don't know what is going wrong with it. I think it may be the case that the page is old and whatever mechanism was in there to unlock it is no longer functioning properly. But you know what, maybe one of you guys could try it from wherever you are and see if you get the same as what I get. This is the address of that page there. So that's as far as I got with regard to finding a schematic. So I'm still flying blind with this thing because this page doesn't seem to work. But I'm going to keep troubleshooting it anyway and see how far I can push it and see if we can get this issue resolved. So back to our TPS-51285B. The description of this again is an ultra-low quiescent dual synchronous step-down controller with 5 volt and 3.3 volt LDOs. So what I wanted to do next was just to check on this chip and see what voltage was present at each of the pins. So I switched my multimeter to volts DC, placed my black probe to ground right here at the top, and then I brought in my red probe. Now these pins are tiny on this. I've obviously zoomed in, so the way I measured for the voltage at each pin was to kind of safely pick out each pin right here that was connected to each of the pins, or sorry, each of the vias that was connected to each of our pins on the chip here. So I carefully did this, and what I found on these were the following voltages. So we have an input of 16.77 volts, which is what we were getting on the main voltage rail that is spread out across the board. And the only other two pins that really had significant voltages were this one right here and this one right here. So when I checked that from the data sheet, we can see that pin 13, which is the one over to the right hand side, is VReg, and the pin over the other side, this one right here, is pin number 3, which is VReg3. And when I look up on my data sheet on that, what it tells me is always on LDO for these models of the chip, the A variety. So we've got what's stamped on the chip is essentially this part here. So we've got the 1285B model, and what they're saying to me there is that's the always on LDO, and that's for VReg3 and VReg5. So what it's telling me there is that this is the always on. These are always present as long as there's an input voltage. There's a 5 volt here at VReg5 and there's a 3.3 volt at VReg3. So I'm assuming that this somehow makes its way across to the power button. But what I'm going to do just to see how this chip actually works is I've got another laptop, a known good laptop, and I'm going to take the measurements from that and just compare them to my chip that I have here. I have an A50-E-158 Toshiba laptop here that uses that same TPS 51285B. This laptop is fully functional, so what I wanted to do was use this as a comparison to my E147, which I found in the sink. So what I did was I carried out the same DC measurements at each of the pins on my E148. So when it was powered off, what I found was that on the pins of my E148, it was very similar. We had a voltage input on our V-in pin, and on our VReg 5 pin number 13 right here, we had 5 volts, and on our VReg 3 we had 3.3 volts. We also had the 4.7 volts on the VBST1 and VBST2, as you can see right here and here, but there were really no other significant voltages on it. So we've basically got our voltage coming in, our 5 volts always on, and our 3.3 volts always on. So that is actually quite similar to our E147, the non-functioning laptop. However, one big difference between the two is that the E148, my functional laptop, has 3.3 volts on the power button, which enables me to power it on, which is what I did next. So when you power on this laptop and take the measurements once again, we now find that our TPS 51285B chip has 3.3 volts on the enable pin, which is down here. It's enable 2. So that switches it on, and that brings up our pulse width modulated 5 volts, which is on this right here. That's SW1 pin 18. And it also brings up our pulse width modulated 3.3 volts, which is on SW2 on pin 8. And I guess the other significant voltage that's also present now is we have P good, which is an indicator that the power is good, on pin 7, and that has now gone to 3.3 volts as well also. So this might actually be useful in the future, because we now have a good indication as to what the pins of this chip should look like when it's on a known good laptop, when it's powered off and when it's powered on. And a lot of these, even if it's not a TPS 51285B, a lot of these chips are similar. They're the similar QFN 20 pin package, and they have, similar sort of data sheets and output pins. So this is actually useful for other chips as well, just to give us an indication as to what it should look like when powered off, what it should look like when it's powered on. The one thing I'm reading from this is that on the E147 that was in the sink, the voltages that are present on this chip are very similar to our functional laptop. So I think that chip is probably functioning okay, even though the laptop was thrown in the sink. We do have the 5 volts and 3.3 volts always on. They are present, but it's just that 3.3 volts is not making it to our power button. I think that is the fault. So let's continue to troubleshoot. Now what happened next is sort of a little bit funny, but you do get these serendipitous sort of moments at times. But while I was doing further checks on my known good laptop, I blew up the TPS 51285B. However, that afforded me the opportunity to then remove the chip. And what I found was when I removed the chip from the known good E148 laptop, that took away the 3.3 volts from the power button. So that made me think for sure that it's certainly related. However, with the chip removed, what I wanted to do then was see if I could feed in 3.3 volts here. When I did a continuity check from here to the power button, I couldn't get any measurement, and when I had it in diode mode it wouldn't measure either. So what I wanted to do was just to 100% prove that this VReg 3 from the TPS 51285B is providing the 3.3 volts for the power button. I wanted to feed in 3.3 volts right here, and see if that made its way to the power button. I think there might be some sort of active element between here and the power button that it needs it needs voltage present in order to switch that on and feed the 3.3 volts to the power button. So that's what I tried next. With a very small piece of fuse wire, a digital microscope, and a lot of patience, I managed to solder that wire onto the VREG3 output pin right here. So that enabled me then to try and inject 3.3 volts at this point. So how I did that was similar to the previous video. I just get my power supply unit, I switch it to half an amp and 3.3 volts, and then place my black probe to ground, and then I just need to make contact with the red probe to that jumper wire. So that's what I did there. Now what I found when I injected 3.3 volts into the VREG3 output right here, I got my multimeter and went over to the power button, and I found then that there was 3.3 volts on it. So even though when I tested for continuity between the VREG3 output here and the power button, I was getting no continuity, and even with a diode check I couldn't get any reading. However, when I inject 3.3 volts at this point without the adapter plugged in, this is the only power source that does make its way to the power button. So that confirms it. On these laptops, that VREG3 is what supplies the 3.3 volts to the power button. Okay, so back to my laptop that I found in the sink. Where does all of this leave us? Well, what I think is happening now is, having looked at the other laptop and how it worked, and then after removing the chip and seeing that when we inject 3.3 volts in at this point that it comes down to the power button, I think what's happening is as follows. I think this chip is actually working. It's not turning on, and it's not turning on because we don't have 3.3 volts at the power button. Now there may be other issues, but that's certainly part of the issue. So I know I have 3.3 volts right here, so I think this chip is good. The difficulty that I see is something between here and the power button is faulty, meaning that we don't have the 3.3 volts on the power button. So I think maybe what I'm going to do, I'm going to leave it at that for the moment. I think what I'm going to try and do next is maybe jumper that 3.3 volts to the power button and see if that gives us a functioning power button, and see if that enables me to switch this laptop on. So I'm going to leave that for this week. That's been a bit intensive. I hope the detail on it, because putting it together was quite tricky to try and make it clear, but I hope it at least came out clear in the video, that everybody understands the different steps that I took there. So any comments that you have, please leave them below, and I'll see you again on the next one.